So what's going to happen on an exam is you're going to get a question that says, can you graph, and I'll put a blue box around this, all of this. 1/4, then the absolute value of 2, and then an x plus 3, and then a plus 4, and put it all together. And what we're going to do is develop techniques for putting these things all together. Technically, the long way, which we're going to skip this morning, would be to start with, right? There's your regular absolute value of x. Then do this first and draw a graph. Then do this one and draw a graph. And then do this one and draw a graph. And then do this one and draw a graph. And then do the last one and draw a graph. And you would have like so many graphs. Frustration level will be like, come on. Okay, so we're going to develop a technique where we can go directly from the first one to the last one. Okay, and the way that we're going to do it is I'm going to rewrite. Here's my last one. I'm going to rewrite it for you. Absolute value 2, x plus 3, absolute value plus 4. And we're going to label what's in all of these numbers. We have to label which ones are vertical, which ones are horizontal. Can you see that the first one is vertical? The next two, I'm going to put H's for horizontal. And the last one is vertical. Because the outside ones are always vertical. What's inside the parent function, which is the absolute value, will be horizontal. Next, I'm going to classify them further. Vertical, is this stretch compression? Compression, because you would multiply, and I'm going to explain it underneath. What's that going to do? It's going to multiply all my y coordinates by 1/4. The 2, it's multiplying, so it's either stretch or compression. This one, compression. You're going to multiply because x's are liars. You're going to multiply your x values by 1/2, not by 2. Next is your horizontal translation. You're going to go 3 units to the x's are liars to the left. And here we have our vertical translation. That's going to go 4 up. Now, instead of graphing each of those, I'm going to look at points on my parent graph. Do all of this math and find out where those points end up. Okay? And as far as choosing, you can choose easier or harder points. So I'm going to do them in red. Obviously, the most important point on our parent graph is this one right here, is 0, 0. Because that's where the absolute value changes. So for sure, we're going to have to do 0, 0. Now you have a little bit of choice on other ones, like the absolute value has 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Like it has so many easy points to choose from, right? I'm going to do a little bit of looking ahead. I know I have to multiply the y by 1/4. And I know I have to multiply my x by 1/2. So I'm going to choose 4, 4 and negative 4, 4. 8, 8 and negative 8, 8 would also be good points. Can you see? Because they divide nicely by 4. And we've done these arrows before. We're going to do them again. But this time we're going to have 2 sets of them. Because I'm always going to do my multiplication stuff, stretches, compressions, reflections first. And then I'm going to do translations second. So above the first set of arrows, I can write that I need to multiply my x values by 1/2 and my y values by 1/4. And above the second arrows, I can write that I'm going 3 to the left and 4 up. The mental math is not hard, but it is easy to make mental math mistakes. So take your time. Like I might do all of my x coordinates here first. X by a half, this will still be 0. This will be 2. This will be minus 2. Then y by a quarter, this will still be 0. This will be 1. And this will be 1. So I multiply my x coordinates by a half. I multiply my y coordinates by 1/4. Now I'll do my x coordinates here. 3 to the left. So that'll be minus 3, minus 1, minus 5. 4 up, 4, 5, 5. I'll draw some axes on my grid. -3, 4. I'm going to purposely lose a half a mark on this question. I'm going to lose a whole mark on this question. No, just a half a mark. I don't want to lose one. Okay. Let's see if you can figure out what I do wrong. Okay, -3, 4, -1, 5, -5, 5. There we go. There is the final graph. And if I did this on a test, I would lose a half a mark. I forgot arrowheads, so that would have lost me a half a mark. So I add the arrowheads. Because that would have been an E9 error. Forgetting those arrowheads would have been an E9 error. But even if I remembered the arrowheads, I'd still lose a half a mark here for something.
Didn't mark any points on your graph.
Didn't mark any points on my graph. If you do not label your points, then you do not provide a scale for your graph. And not providing a scale for your graph is another version of the E9 error. If you make 2 E9 errors in one question, you only lose a half a mark once. So I would have, even though I had 2 mistakes in this one, not labeled and no arrowheads, it would only cost me 1 E9 error. But by labeling it, you provide a scale for your graph, because otherwise, I know it's obvious you want it to go by ones, but if it's not there, they say, I don't know if this is going by 100s, or maybe it's going by 7s, because everybody likes to draw graphs with 7s. So you have to provide that scale there, okay? So I like to draw the arrows this way and do stretches and compressions first, and then translation second. Some people like to see if they can do mental math all in their head all at once. That can sometimes be disastrous because you make mistakes. But this way, we can go from the original graph right to the final graph. If this was on an exam, they would probably make it out of 5 marks. The transformations questions on the exam, I think they're very generous as far as giving you marks. In that, if you show the 1/4 correctly, you get a mark. If you show the 2 correctly, you get a mark. If you show 3 to the left, you get a mark. If you show the +4, you get a mark. If they put a negative, it would be a 6-mark question. If you have the right shape, they give you a mark. So there's a lot of marks in a question like this. Usually, on an exam, if they give you the shape to begin with, they don't have to give you that mark, and then they just check, can you do all of the things to change things? And usually they ask for between 3 and 4. So there's a lot of marks for these graphs. If on the exam, you completely forget how to do this, right? That's not going to happen, but let's say you kind of forget. If on the exam you put in a couple of values, like plug in 0, what do you get? And you plug that point in, and you plug in all the points in correctly and not use transformations at all, this will give you 4 and a 4. So it's a nice backup. If your graph is right, even if you didn't know the correct method of doing it, you can still get full marks on a graphing question. Sometimes though, it's nice to plug in values just to check. Like if you plug in -3, do you see this would be 0? Times 2 would be 0. Absolute value of 0 would be 0. Times a quarter would be 0. And then you would still get 4. So I get -3, 4. I'm like, good. I know that that point is right. You can double check your points as well to see if they're right or wrong. Okay, let's go to example 1. Here's the graph of g of x. Sketch and label its image after vertical compression by a factor of 1/3, then a translation of 2 units up. We need to know where each of these 4 points is going to go. If I want to show my work, I'm going to label that first point as -5, 3, the second point at -2, -3, third point is at 1, 0, and the fourth point at 4, 6. I'm going to do 2 sets of arrows. Okay. If you go online, there's a bunch of different techniques. There's lots of really good techniques for this kind of question. I like doing these arrows. If I have a vertical compression by a factor of 1/3, that would mean my y value is getting multiplied by 1/3. I always do the first arrow with stretches and compressions. Then I have a translation 2 units up. I do translations second. My x values don't change here, so I can just rewrite all of them. And my y values are multiplied by thirds. This is 1, -1, still be 0, and this will be +2. Then I'll go 2 units up, so my x values don't change again. Okay. And 2 up, this will be 3, this will be 1, this will be 2, this will be 4. Okay. Just to show you a different technique, you might, if you go online or see different places, I like this technique as well. So it has 2 columns. And what did we do? We multiplied, our x is not changing, our y is getting multiplied by 1/3, and then we're adding 2. So you could write all of your original points this way. And then look at the formula. Well, on my new graph, my x's are not going to change. So, because x stayed x. And then I have to plug in 3 for y, for my first one. 1/3 times 3 is 1, plus 2 will give me 3. 1/3 times 3 is 1, plus 2 will give me 3. Oh, I wrote that point wrong. I have to change that. Pick up my eraser. Copy the point down wrong. It was a -3 there. So multiply with -1 plus 2 will give me 1. 1/3 times 0 plus 2 will give me 2. And 1/3 times 6 is 2 plus 2 will give me 4. Will my points match up? Yes. Okay. Two different methods of doing the same thing. I like the arrows because I use it a little bit later too. But what I don't like about the arrows is it looks like I wrote a little bit more than this method. I'm lazy, right? Math teachers, math people, they're lazy. They like to write as little as possible. So kind of like the second method for writing a little bit less. But now I can take these points, -5, 3, and I'll draw them in blue. That's a blue point there. -2 and 1, that would be there. 1 and 2 would be there. And 4 and 4 would be there. Connect our dots. Wow. Do I add arrowheads? No. There was no arrowheads on my original graph. No arrowheads on my final graph. So sometimes you're so scared about getting an E9 about using arrowheads, we put arrowheads on everything. But if you add arrowheads when you're not supposed to have arrowheads, it's another E9. Oh. So be careful with that. Now I'm also in this equation, I'm going to write the equation of the blue one in terms of, in this case it's g of x. So my blue equation would be outside the function 1/3, outside the function +2. This would be the equation in terms of g of x. Because we multiplied our y values by 1/3 and then we move 2 up. Now I'm going to do, I don't usually do this, but there's something important that comes up when we do the actual example that they've done as well. So you don't have to write down as much of this, but there's something. We go to their example 1. Move this back off to the side. We're going to do this one as well. Most of it's going to be the same as what we just did, like you. Oh, very quickly, here's the 4 points. I'm going to label those 4 points. So -4, 3, 0, -2, 2, 5, and 4, 2. Label those quickly. We have our stretches and compressions and translations again, so I'll do the double sets. Now, horizontal compression by 1/2, if they tell you what it is, that's what you're multiplying by. Anytime we use this language, I'm going to highlight it here, by a factor of, that's what you're actually multiplying by. So if we say your horizontal compression, be careful because sometimes people will be like, a horizontal compression of 1/2, does a compression and 1/2 kind of like language-wise contradict each other? And that actually is a stretch of 2? No. So if you add the word by a factor of, that just says that's what you're multiplying by. So it's a compression because you're multiplying x by 1/2, and then we're going 3 units to the left. So we can do the math really quickly here. 1/2, -2, 0, 1, 2. Now I'm going fast, we'll probably make a mental math mistake. 3 to the left, -5, -3, -2, and -1. And the y's don't change. -5, 3, -3, -2. -2, 5. And -1, 3. There's our new graph. Now all of this is exactly the same as the other question. That's why I did it really fast. But what I want to really focus on that's interesting here is the equation. Okay? We have x by 1/2, x's are liars, and 3 to the left. So we need to show that in the equation. And because the x's are liars, they add something here as well that will cause you to make mistake after mistake after mistake. All those x's. They just cause so many problems. So, I want you to think of the following. I could write this as, and this is f of x, so everything is going to be inside the function. 1/2 would show up as a liar, as a 2. and then x, and then 3 to the left would show up as a ladder, plus 3. Or should I write it like this? With an extra set of brackets. Can you see that, first of all, that they're not the same? If I distribute this 2 in the second one, I get 2x plus 6. So your question is, do you think this equation should be 2x plus 6 or 2x plus 3? Because that's what these two versions are. Okay? Your gut feeling would probably like the plus 3. Correct? Because you see it going 3 to the left. And because x's are liars, this is definitely going to be wrong. Because that's what your gut would go with. Oh, those x's. When we have, and we're going to write a special note. So at the bottom of page 221, we can even put this. Here, I'll do it on red. Red seems like it's wrong. Special note. I'll do it in purple. Purple seems better. Special note. When you have a horizontal either stretch, compression, or reflection with a horizontal translation. When you have both of those things together, two horizontal things together, you must write the equation in factored form. Vertical stuff, this never comes up as a problem. Horizontal, it comes up as a problem. And it comes up as a problem now that we're combining things. In fact, if you look at the very first example that we did, I'll come back to this in a second, but if we look at our very first example, do you see in the blue box? They had it in factored form. They had the extra set of brackets. They didn't write this as 2x plus 6. They wrote it as 2 bracket x plus 3. And I didn't pay much attention at that point. I just said, oh, 3 to the left, blah, blah, blah. Okay? But if it had been written as 2x plus 6, our gut would see that plus 6 and think 6 to the left. And it would be wrong. So the correct way of writing a compression of a half and 3 to the left together would be in factored form. This comes up on your first test like lots. I think I have it on the first test like 4 or 5 times. So if you forget it, that's 4 or 5 marks gone right away. Okay, I had one student set a reminder on their phone for 10 p.m. every night. 10 p.m. every night, they're like, bloop, special note came up on their phone, reminder. When you have a horizontal stretch, compression, reflection with a horizontal translation, you must write the equation in factored form. Every night they get a reminder. I mean, that'd be awesome, but if you do every important thing for this course as a reminder, By the end of the year, it's gonna go from 10 PM to like 1 AM, 3 hours of important reminders. Not a bad idea. But this one in particular is so easy to forget. You will all forget it at least, I don't know, 7 times. You're gonna make that mistake 7 times at least. It's gonna be hidden. Sometimes you're gonna be like, I didn't see it. Well, yeah, this comes up quite a bit. Anyways, questions for the first one. Circle 4, 5, and 6.